All right, homework day 35 says a word problem involving multiple rates. There are two machines that produce aluminum cans. The new machine can produce 4,200 cans in 210 minutes. The older machine, 280 minutes to produce that many cans. If the two machines work together, how long will it take them to produce that many, or to produce 4,200 cans? So we're going to find the rate of each machine. The new machine produces 4,200 cans in 210 minutes. So if you divide 4,200 by 210, you figure out how many cans that machine does each minute. So if you divide that, you get 20. So this one's producing 20 cans every minute. The old machine takes longer. It's still going to do the 4,200 cans, but it takes 280 minutes. So again, if we divide, we will find out how many cans each minute that one does. 15. So we know that if they work together, this one does 20 cans a minute, this one does 15 cans a minute, that they can do 35 cans every minute. They're still going to do the 4,200 cans at a rate of 35 cans every minute. So now we're going to take the 4,200 and divide it by the 35. 120 minutes. So the first one would take 210 minutes alone, the second one 280 minutes alone, but if they work together, it's only going to take them 120 minutes. So an aquarium tank can hold 5,400 liters of water. There are two pipes that can be used to fill the tank. The first pipe alone can fill the tank in 90 minutes. The second one can fill it in 60 minutes by itself. When they both work together, how long will it take them to fill the tank? So the first one, we have 5,400 liters of water. It takes 90 minutes. How much water is it pumping every minute? 60 liters per minute. The second one's still going to do the 5,400, but this one takes 60 minutes by itself. So it is pumping 90 liters a minute. So if they work together, how many liters per minute do they pump? If they work together, they're going to do 150. You already divided, didn't you? So if they work together, they can do 150 liters every minute. And if we take 5,400 and divide by 150, we then came up that it took 36 minutes in order to fill the tank. Bob and John are rinsing dishes. There are 480 dishes that need to be rinsed. John can rinse them in 80 minutes by himself. His friend Bob takes 120 minutes. How long will it take them if they work together? So John does it in 80 minutes. How many dishes does he rinse every minute? 6. Bob takes 120 minutes. How many dishes does he do by himself? 4. So John does 6 dishes a minute. Bob does 4 dishes a minute. That means they're going to do 10 dishes every minute if they work together. How many minutes will it take them to rinse all their dishes? 48. Now the next ones are going to look just like the word problems on proportions, because that's what they are. They're going to call them direct variation. Again, when I'm looking at a word problem, if it's direct variation, if I increase one thing, the other thing's also going to increase. If I'm doing miles per hour, the more hours I drive, the more miles I'm going to get. It's a direct variation problem. I can set it up as a proportion. So for a moving car at a constant speed, the distance traveled varies directly with the time spent driving. If such a car travels 210 miles in 3 hours, how long does it take to travel 700 miles? Just like the ones you did that they called word problem on proportion, we want to make sure if my miles are on top here, that my miles are on top on the other one. So 700 miles in how long? And again, we're just going to cross multiply to solve. So 210x is going to equal 3 times 700, which happens to be 2100 then. And if I divide, I'm going to get 10 hours. So if I go 210 miles in 3 hours, I can go 700 miles in 10 hours. My miles increased, my hours increased. Number 5, on a given planet, the weight of an object varies directly with the mass. Suppose that an object whose mass is 9 kilograms weighs 81 newtons, that's what that N stands for. Find the weight of an object whose mass is 5 kilograms. How could I set up my proportion then to solve that?
So would it be 9 over 81?
9 over 81 would equal
5 over x.
5 over x. Since we had the kilograms on top here, we also have the kilograms on top there. And so 9x is going to equal 5 times 81. 405. And if we divide that by 9 then, 45 newtons then. So here, my mass went down, so did the number of newtons, right? And number 6, it says, suppose that the distance a car travels varies directly with the amount of gasoline it uses. A certain car uses 15 gallons of gas to travel 435 miles. The car travels 377 miles. How much gasoline does it need? So I'm going to start off with
15 over 435.
15 over 435. That's going to equal
X over 377.
X over 377. Exactly. My miles were on the bottom of the first fraction, so they're on the bottom of my second fraction. Cross multiplying 435x is going to equal 15 times 377.
5,655.
5,655. And then, of course, I have to divide.
So that would be 13 gallons.
13 gallons. So if I had 15 gallons, I went 435 miles. If I only use 13 gallons, I'm only going to get 377 miles. By the way, if you look at the Alex explanation for direct variation and inverse variation, they're going to do it a total different way, and they're going to find the constant of variation first, which you can do, and it does work, but it's a whole extra step to solving the problem. So, if you want a shorter way, look at Linda's notes. If you want the long way, do it the Alex way. Inverse variation. Inverse variation, when one thing goes up, the other thing will go down. The more workers I have, the less time it takes me to do a job. These ones, it's going to say varies inversely. You'll know it's inverse variation. But instead of setting up a proportion, which involves division, we're going to set it up as multiplying. So the two given things will be multiplied together, and that's going to equal the two other things multiplied together. So it says, suppose that a constant force is applied to an object. Newton's second law of motion states that the acceleration of an object varies inversely with its mass. A constant force acting upon an object with a mass of 15 kilograms produces an acceleration of 5 meters per second squared. The acceleration of another object produced by the same force is 3 meters per second squared. What is the mass of the object? So I'm going to take 15 times 5, that's the given, and we want to know what is the mass if it's 3. So the mass times 3, or 3 times the mass, whichever way you want to write it down. But I'm just multiplying the things that go together instead of dividing the things that go together. So 15 times 5 would give me 75 equals 3m. And if I divide by 3, 25 kilograms is going to be my mass then. So when my kilograms increase, my acceleration had to decrease. They go in opposite directions. One goes up, the other has to go down. So number 8, Boyle's law says that a volume of the gas varies inversely with the pressure. The higher the volume, the lower the pressure. When the volume of a certain gas is 2 liters, the pressure is 1,025 kilopascals. What is the volume when the pressure is 410 kilopascals? So how should I set that one up?
2 over 1,025.
Nope, that would be if it was direct variation.
So 2 times 1025.
2 times 1025 is going to equal
410K.
410 times whatever the other one. I'm going to use V because it says what is the volume. So 2 times 1,025 would be 2,050 equals 410 times the volume. And if we end up dividing there by the 410, five liters. So my pressure went down, my volume increased. We have Boyle's law again because they like to use that one. It's a good one from science class. Boyle's law says the volume of gas varies inversely with the pressure. When the volume of a certain gas is 2 liters, the pressure is 575 kilopascals. When the volume, or what is the volume when the pressure is 5 liters? So how would we set that one up?
2 times 575 equals 5 times V, I guess.
5 times the volume, or whatever variable you want to use. So 2 times 575 would be
1,150.
1,150 equals 5V. And if we divide by 5 then, 230. 230 kilopascals. So this time my volume increased, my pressure had to decrease. So when it says right in there varies inversely, that's a big clue. The next ones are going to be inverse variation again, but they're not going to tell you it's inverse variation. They want you to recognize when you read the word problem that it's an inverse variation. It says, how long will it take 5 workers to complete a task given that 6 workers can complete the same task in 10 days? If I think about it, the more workers I have, the fewer days it should take me, so I have an inverse variation problem. The given information here is that 6 workers can do the job in 10 days, so 6 times 10. If we have 5 workers, how many days is it going to take me? So just like the previous ones, I'm multiplying the given information together because it's inverse variation instead of direct variation. So 6 times 10 is 60. If I end up dividing that by 5, it's going to end up taking me 12 days. 6 workers can do it in 10 days. If I only have 5 workers, it's going to take me 12 days. Takes me longer. So number 11 says, how many machines will be needed to complete a task in 3 days, given that it takes 4 days per, that's probably supposed to say 4, 6 machines to complete the same task. So, if I know it's going to take 4 days for 6 machines to complete the task, 4 times 6, we want to know if we have 3 days, how many machines? 3 times m, whatever you want to use there. So solving that, 4 times 6, 24 equals 3m, and if we divide by 3, how many machines do we need? 8. So, takes 4 days for 6 machines. If I only have 3 days, I need 8 machines so I can get my job done. And the last one, suppose that 3 workers can complete a certain task in 10 days. If there are 5 workers, how many days will it take them to finish the same task? So I've got more workers, it should take me less days. How should I solve that?
3 times 10.
3 times 10 equals,
5.
I'll say 5 times D since I'm looking for the number of days. And so 30 would equal 5D. And when I divide, I would say my answer is 6 days. So 3 workers take 10 days. If I have 5 workers, it's only going to take me 6 days to get the job done. All right, that is the end of chapter 5. It was fairly short. So hopefully something you can whip through pretty quickly. I don't think there was